Students, I am going to discuss a problem of equilibrium. The problem is a uniform rod is made to lean between a rough vertical wall and the ground. The coefficient of friction between rod and the ground is mu1, and that between rod and the wall is mu2. Find the angle at which the rod can be leaned without slipping. Okay? Here you have a rod that its length is L, so its weight like W. So it acts at the center of gravity. It will be L by 2 and this will be L by 2. Okay? Now here the normal action. This is N1 at this end and N2 at this end. The rod tries to slip this way, so friction acts in this direction F1, and here it is F2, because this end tries to move downward direction. Okay? Now let theta is the angle which we needed. Okay? So as the whole rod is in equilibrium, so the equation of static equilibrium we can use for the translation as well as for rotation. Okay? Here the friction force F1 is equal to mu1 N1 and F2 is equal to mu2 N2. For the translation equilibrium, we can write summation for translational equilibrium. We can write summation Fh is equal to 0. Net force in the horizontal direction 0, or in horizontal direction there are two forces, one N2 and F1. So N2 minus F1 is equal to 0, or N2 minus this is equal to mu1 N1, so it will be 0. Okay? Now let this equation first. And in vertical direction, summation F V is equal to 0. In vertical direction there are three forces, 1 and 2, another one is the weight in vertical downward direction. So we can write this N1 plus F2 minus W is equal to 0, or N1 plus mu2 N2 is equal to W. Okay? On solving these equations, above equations, we have N1 is equal to W upon 1 plus mu1 mu2, and N2 is equal to mu1. Here it is mu1 W upon 1 plus mu1 mu2. Okay? Now as this rod is in rotational equilibrium also, so we will write for rotational equilibrium summation tau about any axis. For simplicity here we take this and A, so about A is equal to 0. Okay? Now moment of force of the weight, here the line of action, here this distance is L by 2 cos theta, so it will be W into L by 2 cos theta, and minus that of the N2, its line of action is at a distance, here it is this L sin theta, and this distance, that is the line of action of F2, from here it is L cos theta. So we may write this minus N2 into L sin theta minus F2, that equals to mu2 N2 into L cos theta is equal to 0. Okay? Now on substituting the value of N2 and simplifying, we have tan theta is equal to 1 minus mu1 mu2 upon 2 mu1. Okay? So here theta is the required angle, so we can write theta is equal to tan inverse 1 minus mu1 mu2 upon 2 mu1. Okay? Thanks for watching the video.